This presentation is delivered by the Stanford Center for Professional Development.
Welcome to EE380, Stanford Computer Systems Laboratory Colloquium, Fall 2012-2013. This is the last talk of the quarter. I'm Andy Freeman. The other course organizer is Dennis Allison. I'd like to remind students taking the class to get all your assignments in, no incompletes. Today's lecture is part of the Computer Science Department's Distinguished Lecture Series, so the speaker introduction will be done by Professor Lee.
Thank you, Andy. So yes, welcome to the Computer Science Department Distinguished Lecture Series. In fact, this is the first one of the academic year. We have one per quarter, and we highly encourage students to attend these very high-quality talks. My name is Fei Lee. I work at the CS department as a part of the AI lab faculty. So it's a great honor to really have Dr. Harry Shum here. He's a long-term friend, colleague, and mentor, and has given me a lot of great advice along the years. And I guess Palo Alto is so honored to have Harry. It offers you the Seattle weather as a welcome. So Harry is really one of the most distinguished luminaries in the areas of computer graphics, computer vision. He graduated from CMU with the PhD specializing in graphics, and then he was just telling us his distinguished career. He actually did the Silicon Valley thing, which is a startup, and then Harry said that two things don't mix in life, was startup and baby. So he decided to, when he had his first son, he decided to go to Microsoft research. What a great choice. We wouldn't have had been and a lot of great things. So Harry was part of the founding team of Microsoft Research Asia, researching in China, and then renamed Microsoft Research Asia. And that was around the time I personally met Harry. He was just tremendous. He built an incredible research team there. Every year you just see dozens of papers published in CGraph or computer vision from Microsoft Research Asia. And he did so well, I think probably Bill Gates or whoever personally invited him back to Microsoft as a corporate VP to head the Bing development team. So without further ado, let me hand over this podium to Harry. He's going to tell us about the interesting things he did at Bing.
Thank you, Fei. I was really worried that if I can add any value to Stanford, especially back to the CS department. I used to hang out with Michael Lavoie, Pat, Chris Bregler, those guys when I was working on vision and graphics. But I thought at least I'm already making some contribution by bringing Seattle rains. I'm sure you guys here need a little bit more water. I used to work as a researcher in Microsoft for many years, and until 5.5 years ago, then I was kicked out of research and got a real job. That is hacking code and building Microsoft search engine. Before I talk a lot about some of the details, to whatever extent I can share with you about what we do in Bing, and let me also caveat that, and given that I'm no longer a serious researcher, and now I'm a lowly engineer hacking code, so there's very few equations in this presentation, and very shallow as well. Hopefully, you also find some value out of this presentation. Stanford is a place that, as a CMU graduate, I want to be especially respectful. So before I actually get into my presentation, I actually really like to do that, and just to make sure that I understand this audience. How many of you here have heard about the Bing? Wow. So how many of you have used the Bing? Wow, this so far so good. Okay, how many of you regularly use Bing? Now we hit the problem. And I think you think we should get the names and make sure that we send them some T-shirts. And that's one of the problems I'd like to just share with you and in this battle with Google, and just almost impossible.
Does that include Mrs. Beasley or whatever?
I don't. That's however you interpret. Even that, we have what, 2 hands. I had the chance to talk to Hector this morning, and happily set his Chrome default search to Bing, just so you know that you can actually do that. And just for the heck out of this, and just for fun, and how many of you here actually work for Google? That's good. And that is a question for you, Yoav. And so even that, we'll be very transparent about what we do. And the title of my talk is actually Intent Knowledge and User Interaction. It's really mostly how we think about how to design the product, the user experience. So let me start by saying it has been quite a journey building a search engine in Microsoft. I just want to make sure that we actually have a little bit of historical perspective, how difficult the problem was, and it still is. I did not really plot a lot of historical data. Let me just say that ever since Google happened, which was a great thing, and it happened right here at Stanford, and ever since Google happened, and Google just moved like this, and just eating lunch from every other search engine competitor, and rightly so, because the product, the quality was so much different. And you can see that from 2005 to 2009, and both Yahoo and Microsoft lost 10 points each, and Google actually picked up 20 points. And I stopped at here is actually really when actually we start to get very serious and relaunched the product as Bing. So we worry about it, and we care about search, and we talk to a lot of industry analysts and the people, experts like Danny Sullivan, and Danny actually writes this the blog. If you actually ever care about the search, and you should regularly read Danny's blog, is actually called searchengine.com. He came to Seattle fairly frequently during that period of time, so we talked to him, and I actually shamelessly plagiarized his picture, this Google cigarette. His point of view was that still very valid, is saying that Google has become such a strong brand. It's actually even beyond a brand. It's almost like a brushing teeth, and it's almost becoming a habit. And a habit doesn't mean a good habit. So a habit could mean like a smoking. So for those of you regularly use Google, just go home and think about every time you use Google, and it's like a smoking Google. And it doesn't kill you, as Danny said, but it could be harmful. So that's really when we actually look at all those difficult problems, and hopefully you will enjoy this video actually put together by our marketing colleagues, and it's really started our journey.
Search, the final frontier. This was the challenge for our enterprise. Our 6 multi-year mission to give us new life and new modernization. To boldly go where someone had gone before. The year was 2003. The year party what it needed was a bold new name. We tried.
So, I'm just going to make some marketing jokes, and someday I'm done with my engineering career. I would really want to move to marketing department. It's a lot of fun. All you need is spending money and creating. creating videos. And but really, jokes aside, a lot of people ask me, how did you guys come up with this name Bing? And there was a lot of hypotheses. And there's Bing is not Google, so B-I-N-G. So Bing is not Google, but it's not Google. And there's a lot of things, and we have internal jokes as well. But I give you official answer why we actually named our search engine Bing. So the fact is that as we get more and more online, use search engines more and more, and we just become lazy, and we actually start to forget about things. And in fact, I actually don't even remember a lot of phone numbers anymore. And now I can hardly remember my wife's because it's all stored there. Similarly, for any kind of interesting things, such as the websites, and you just don't remember anymore because you have a search engine. So the hope is really, as time goes on, we will all forget about 6-letter words, and the only thing we can remember about the 4-letter words. And by then, I think you can only remember Bing. So then we will win. So we have come a long way since we launched Bing. So I share with you a few numbers. I feel very proud of our team, engineering, marketing, all together. So in the US, the unique users, we actually have increased by about a third. Now we have roughly about 100 million unique users monthly. And the Bing market share, and you saw the picture before, and by the time we launched this new brand Bing in June of 2009, we had only about 8% of the market share. So now we have actually about 16% of the market share. We also power Yahoo's backend. So plus Yahoo's, we have actually close to, not quite, but close to 30% of the share in the United States. And one thing that we have done very well is actually brand awareness. Clearly that everyone in this room heard about the Bing. So it's an added awareness is basically saying you go on street, ask any random Joe, you just say, have you heard about the Bing? And actually, clearly a lot of people in the United States now actually know Bing as a brand. It's actually not easy. So the quality is really getting better. So that's something that me as the head of the engineering feel tremendously proud. I hope throughout my talk, with a lot of examples here, and you go home, give it a try, I do feel our quality is at the point that it deserves to get another look from you. So that's the thing. I show you a few quotes. We constantly talk to people like Danny. And Danny is saying the most important point that is Google is not always better. Let's just be clear. I show you some examples in my talk. There's other analysts saying, well, it's always another look, and they look at the interface is good, it's fast, and most importantly, it's actually relevant. So there's someone actually has been writing yearly post about the fallacy of the superior search engine. The point is really something I want to make that as well. Try it yourself and see if you really agree with me, and see how good the Bing search quality is. And at the end of the day, the most important thing for a search engine is finding stuff that you are looking for, and that's first and foremost is still the core problem. And I do want to just share a little bit of experience with you that it is a consumer product, it is a brand. It's very, very difficult to build. If we look historically, and things happened, a few very famous brand wars happened, especially in the United States. The most famous one is, of course, Coke versus Pepsi. There's this famous Pepsi challenge, and it's just say, you take a sip, see if the Pepsi is actually better than Coke or vice versa. I would say I'd be happy to take a Pepsi's market share any day, if Bing can get there. Coke is still winning, but I think Pepsi has done a really good job. So the second example I have is Avis versus Hertz. I mean, it's really hard to differentiate. You got to realize, you go to rental car, what more can you really provide to other people? And my rental car is better than yours. And it's just very, very difficult. But at least Avis has this tagline say, you know what, we try harder. And in this day of time, and unfortunately consumers don't really give a damn and say you try harder, so therefore I am going to use you. I think it's not clear to me, it's really that great example. And suddenly you have McDonald's versus Burger King, and have FedEx versus DHL. Tons of examples there. And but as long as this industry is still making a lot of money, people will have second product coming in and try to compete. So what we have done, we have done a lot of things, and over the last 3 years, and the latest one is actually something we call the Bing It On Bing Challenge. It's really a website. You can give it a try. It's called bingiton.com, and there's the Bing Challenge. So you can actually go to that website and think about the 5 queries you want to compare, and then you vote which one wins. And it's really the blind test. If you really look carefully, you probably still can figure out which font color really used by Google. And but if you don't look too carefully, you can ignore the branding effects and you look at that. So we actually did some user study. We found that a lot of users actually prefer the Bing results. But it's really hard to say. And I talked to a lot of people. We try to come up with this industry forum. Why don't we just bring all the search engines, the Google, Bing, Yandex, Baidu, come together, have this industry forum, and maybe can just happen here in Stanford, compare with search quality, agree on certain metrics that we can all measure, and then we see how it goes. But it hasn't happened yet. So we started this thing called Bing It On, and you can take a look at that and let me know if you found if you are pleasantly surprised that the Bing is actually doing pretty well, and give it a try. So that's the thing. And but this is really no guarantee. We have been TV ads and online ads and try to convince people to give it a try, and with some moderate success, I would say. It's really hard. The key point is that consumer brand is really, really hard. And let me show you a video you may have seen on some of your local TV stations. Let me roll it.
I bet you an Xbox 360 that you would pick Bing over Google. If we do a side-by-side blind test comparison, and you end up choosing Google, you get an Xbox. But if you choose Bing, that means I'm right. Now you get to have your sweatshirt. Why don't you look at the picture and get your sweater? Yeah.
All right. Hot fashion sweater.
All right.
All right. I'm taking the right.
Bing won. So strip it and dip it because that is now my sweater. It looks like Bing won. So it looks like you're going to have to embarrass yourself by running across the street in your underwear. You are a Bing man.
People show web search results do what they want. Show that 5 million people who visited .com.
I hope you have the same appreciation as I do, for marketing folks. And when they showed me this, they said people prefer Bing over Google 2-1. I almost fainted. I said, here goes my scientific research career by making such claims. And at least my name is really not associated. So let me just show you a couple of examples. By no means I'm saying that couple of examples really saying Bing is definitely better than Google or not. I'm just encouraging you to really give it a try. And every day, as I told Amit Singh, every day, every morning I get up, I use Google. I just have tremendous respect for Google engineers, what they have done, the search quality they have improved over the years. Incredible job. It really brings the best out of the Bing engineering team as well. And I feel very motivated every day competing with Google. I show you an example, and I don't know why Google didn't get it. And for those working at Google, maybe you can go back and ask them. And the query is actually why Google is no longer king. And there's actually a blogger actually wrote this blog with the title of why Google is no longer king. And Bing got it at number 1. And Google doesn't. And Google just did not get this result. And not at number 1, not at the first page. And I clicked a couple of pages I didn't find anywhere. So just the examples and after examples you will feel. So my suggestion to you is that at least the next time you try, if you don't find something on Google, give Bing a chance and give it a try. Let's be very clear that search is such a difficult problem. It's just so difficult, and it's just that the users are not very cooperative, and they often type things wrong. And the people like me who are not native speakers, very often have problems, really do the spelling right. And Arnold's last name, for example, Schwarzenegger, and I can never really spell. And I suspected probably no more than a couple of people can really spell. But nowadays, you don't really worry about it. You go to the search engine, you actually give it a try, and they actually correct it for you. So I'll give you an example here. Say, we actually believe that this user really meant the nicotine withdrawal. And so this guy just typed this thing, and so I actually think we got it right. And we look at the Google spelling result. We respectfully disagree with Google here. We probably get it more right, but you never know. You just never know. And so I give you another example. Google actually has done better, which is much to my dismay. I am here in Stanford. I really want to pay the respect to John. And we tried to type John Hennessy, and then we actually end up with John Kennedy, and Google actually did it right. I guess Larry and Sergey did pay more attention to any name from Stanford, so.
Yeah, and they're a board member.
Yeah.
Actually, Google has always had a subtle Stanford bias from the beginning.
Yeah, I'm sure it's a positive bias,
It used to be John.
You got to absolutely push those MIT names down, make sure those Stanford names up. So my point here is that just say it's a very difficult problem for many years, and the part of Google magic is their speller. And you talk to Amit, you talk to those guys there in their core ranking team, you would absolutely see the sense of pride from that team. And I want to make it very clear that our internal numbers shows that however you measure this speller quality, and with latest release from Bing, we're neck to neck. And be happy to talk to those folks more. It's a hard problem. None of us really gets it right every time. So it probably makes sense that there are more search engines really competing, just like doing research. So talking about the search quality, that's really the most important thing that for search engine. And we work really hard to look at the overall the search quality. And anytime you have an engineering problem, you have to have some kind of metrics, and you have to be very clear, especially as the head of engineering. I have to stand up every 6 months telling my teams, see, that's what I care. For the last 5+ years, I have been extremely consistent. Say, only 3 things I truly care about search quality. That's the relevance, performance, and the experience. So relevance really goes without saying. You just have to make sure that you get the right result, you get the better result on top, and simple as that. Performance, no one is going to wait for 2 seconds to get the results. And it's extremely important. It's a huge investment at back end, and from your data center to your networking to the rendering. And you have to really think about end-to-end. A lot of problems, a lot of engineering problems there. The last one is really, it's a consumer product, and it's really about the user experience. I was talking to the host of this class and the lecturer of this class, and beforehand, he said I didn't get his name. He said he has many questions for me afterwards. Is overall the way to really do search with a white box with a few words, is this really even the right thing to do? I think we can debate about that, but no one.
What about advertising revenue? Do you pay attention to that?
I do, but I don't have time to talk about that. And the advertising revenue for sure. And look, I never had a chance to really talk to Larry and Sergey. Let me just hypothesize that the night they recognized how much money they were sitting on, I bet they couldn't sleep that night. And then you go from a fun research project, graduate student project, to really saying there's an unbelievable business model that you can make so much more money. And it's really very important. But for this particular talk, I'm going to focus on user experience here, search experience here. So I really want to just slowly take you through. There's a kind of, very important recognition from my point of view and from being engineering point of view, how we actually really think about the user experience. And the more or less that, for 4 or 5 years ago, it was more or less that, it was really what I call the search hit or miss model. It's really about you give a query, then we give you 10 results back. It's all the web documents mostly. So the job there is really saying understanding the query enough, lexically, and then we indexing the words and try to do matching. Then we try to compute the relevance. End of the day, the result is really the relevance of the 10 blue links, 10 web documents. So put that mathematically, what it really means is really minimizing the time of query URL matching. So you really want to get the query and the URL match and get you out of there. And a lot of those queries, the early days, is really mostly navigational. It's really say, do you want to get to this particular Walmart somewhere, some hotel, So So that's really the model for many, many years has been very successful with the simple white box, you get a lot of information you need. But we actually believe that it's really getting to the next stage. More and more as people use search engines, they are not satisfied with only getting to a particular website. They actually come to search engine with something in mind, some kind of tasks in mind. They just don't really know how to express the intent. So we really need to understand the intent more contextually about the user, about the locations, about other things. And we really need to get into more details and a lot more semantic meanings about the documents as well. And so that we can actually match better. So then it's really talking about the relevance. It's not only just the query to the URL or to the document. It's really the query to the URL and the entities. Entities here are really just the proxy of what is really, what knowledge really is here. And then I would say, mathematically, this problem can be really redefined as really about minimizing the time for the user to complete the task. Previously, really minimizing time of query URL matching, which is still important. It's still kernel of this whole problem. But I would say I'd like to reformulate this search problem to minimizing time of task completion, except that it is a very difficult problem. You don't know the task. You just don't know the task. The user has no ability, and we cannot design the right user interface for the user to express what exactly. It's just on the way back to work, I just heard from the NPR, there's this new drug, there's some researchers, somewhere, some organization in Seattle, and some guy did something, and with some name I don't know, Kati, so some guy's name, and so then you try to piece something together. Really want to get to that. This young researcher and whose father is actually a Stanford professor who actually did that, and somehow many steps later you actually get that. So it's really not about one particular search. It's really more about the entire session and whether you can really get there. So I really think that we're getting there. If you agree that is really what people are searching for, then you actually have no choice but to design the product as a dialogue. It's really step by step to carry the user to what the user was really looking for. I think that's why we actually say, we have to go to a dialogue model and providing more useful, more relevant information every single step, but with the objective in mind that at the end of the day, it's really about getting to the task completion, yes.
So do you think that's because people assume that search engines can, process a very complex query and then they do a dialogue-based model? Or do you think that's essentially how humans work?
I think it is probably both. Here's how I think about this. I think we, of course, get trained, and mostly by Google and the other search engines as well. So got trained, say, well, you try something, if you don't get that, then you got discouraged. I mean, the humans are more or less the reinforcement learning machines. So then you look at this, well, if you cannot get a lot of things, then you just don't try. But of course, people forget, they try again. And then you have the younger generation, they actually are more brave to try those different things. And there's also, I would say, the technology-wise, is just not that easy to do. And if you look at where we are in terms of search engine, by and large, is still more or less what we do with the web graph. What we do with the web graph, where each document is actually indexed more or less just the words. And we're adding more and more metadata. We actually injecting more and more entity and the relationship and those things. But the architecture today is more or less stays the same. And there are reasons, for example, that you go to Google, for example, if you input more than 32 characters, and the rest will be ignored. And there's a reason for that. It's not that they cannot do more, and there's economic reasons why you don't really process that much. So I think this really both sides. The technology is not ready, and people give it a try, and they get something. If they don't, then they move on. We need to design the system in a way that is the experience needs to be good enough, so the user will continue to try, then they continue to give you more data, then you have a chance to improve.
Well, if you had the perfect search engine, do you think people will still engage in dialogue?
There is no such a thing called a perfect search engine.
Sure,
and so I actually love this search field because I used to work in research. To me, I think search is such a perfect research problem because you don't really know the answer. you struggle to define even a metric, what you are really optimizing. I'm presenting one particular way of looking at this problem, but it's just a particular way. If we bet it on right, and we might make a lot of good progress. If we bet it wrong, too bad. Okay? So that's really the way we look at it. Then you say, well, then how do you put together the search engine? And then you have to have some kind of notion that what is your architecture there? And the way we like to think about it is really more along the line of, what is the information architecture? What are you trying to convey to the user that the user is going to see, right? So then we say, well, we actually would like to design the latest one, and from Bing, and that what we do is actually 3 columns layout. So we still have the traditional URL results. It's still at the most prominent space. That's what the people mostly still looking for. That's what we call the web nodes. And we are going to extend the middle one, what we call the Bing nodes. And it's really mostly about the entities and the more knowledges, what we do here. And the far right is actually what we call the what friends know. So that's actually how we think about those 3 different ways to do things. It's not like we cannot mix, but we would rather start this whole thing by being very clear to the user what you can expect. Again, it's kind of training the user to get to a point, then the feedback you get from the user makes even more sense. So you say you have web nodes, the traditional web results plus some answers, and then you have the entities knowledge is there. Then you say you have the using the social data from social network, from Facebook, Twitter, and the others, and we can show a lot of interesting results there. So that's really the information architecture here. So let me just use the Stanford example here. So if you look at Stanford now, we actually have 3 things. Actually, it's logged by my colleague Yu Ting, and if you log on Facebook, and then we will be able to show you a lot of results, leveraging your Facebook data. So on the left, then you have this what web nodes, and if you have Stanford, of course, you want to get the Stanford University here. Then you have the entity here. That's what we do, and then the lot of useful information about Stanford and the related people and the people who also searched Stanford. It's kind of interesting to look at that. People who searched Stanford also searched Harvard, Yale, Princeton, and I would assume that's Berkeley. Then on the right-hand side, there's a friends know, and Eating's friends here, and I think Ian Ling actually, was also a student here. Barney was a student here, and some other people also know something about the Stanford. So this is really sort of a setup, for my somewhat technical talk, how we actually really formulate this problem, and hopefully that's clear enough to you, how we really look at this problem space. So the problem design is actually more complicated, more complex than I actually thought, and I thought I understood before I joined the product team. Turns out that put together this search result page is more complex than I thought. Being a technologist and a researcher before, and I just did not understand it enough. What's really going on there. So the way we think about now, put all those things together, we say, well, we actually really understand now. We actually have an architecture we would like to follow, and we would like to have a model behind how we actually put every piece together on a page. And it's really a dialogue model. And if you care enough to just bear with me for a few minutes, I walk you through the system that we actually think about the modeling here. It's really a stateful feedback system. There are 3 loops here, and I skipped the big loop. That is actually why did you design this kind of product features? So it's a little bit abstract here. I will come to the concrete example after this slide. So if you think about that, so you say, well, you design something and you believe that the user behavior will be like this. Then the important thing is actually you build an intent model. Say, if you type this kind of query, that's how I interpret your intent. The concept there, the topic is there, and the entity is there, and all those things. And then you show something, of course, then you have the page there, the user will interact. So the user goes through this whole interact model, then something happens. So then we actually say still, log the user behavior, from clicks to browsing to other things. Then we come back and we say, did this feature really achieve what we actually want? For example, your number 1 result, you actually really want to have more clicks. For example, your number 1 result, you really want to have more clicks than number 2 results. If that's not the case, then you should think about it. So those are really just a very simple examples to how we actually look at this. So that's one main loop. So the second loop here is actually what we call the knowledge and the memory here. Memory is really short-term knowledge. That's another way to really think about it. Say, well, in order to interpret this intent, and I actually would like to have some understanding about some things. Let's take Stanford. So Stanford actually turns out to be mostly is a university, and it's also a location, and also a name of a hospital. There are many things, so you have to have this kind of knowledge here. Then you use that to really infer the intent, and you can also use some of the short-term memory, like what happened in the previous click, what happened in the previous query. There are a lot of those interesting things there you can also use. So that's really overall, how we actually really think about it. Of course, there's a big loop, as I mentioned earlier, is if you don't like this design, and you have another loop, it just changes the whole thing. So that's somewhat at a high level. But if you actually get down to more details, then you say, well, no, exactly what kind of dialogues did you really design for your product? And they are very different, many different levels. I just point out a few here. They could be the document level, and you can really say a lot of things about the URL, the documents. And it could be query level, and it could be page level, and it could be session level. So those are different things. So I'll show you an example here, some very simple example. And starting with something you should be very familiar with if you use search engine. So this thing called a simple and explicit query level dialog. So let's say you type Stanford. You actually want to type Stanford. You type Stan-F here. So for me, the first result coming up is actually Stanford EE380. Now this is also highlighted. The reason for that is actually I did search for this before. So that's actually my short-term memory. It's actually my search history here. You don't have to log on Bing or anything. We already provide that. It's actually a very, very useful feature. It's actually some number you might be curious to know. It turns out that if you just log your search queries for the last month, and then you do our statistics, you should send me your numbers if you don't believe me. It turns out that 50% of your queries that you already queried before. So roughly about a half. So that's why we look at the user behavior. We say, well, it's actually important that we provide the search history here. And then you have a lot of other suggestions, Stanford University, Stanford football, and all those things. Apparently, a lot of people, they actually typed. So those are really from the aggregated user behavior, of course, anonymous. So that's actually something you see every day. We call the auto-suggest. So that's the example here I just talked about. So here's the second example, say, speller, correction here. It's another very simple dialogue. Then you say you type this in, you really want to type those Stanford Cardinal. And it turns out that you mistyped it, and you actually have STANDFORD, and it's just, and the speller is smart enough basically saying, well, it's probably wrong, and we actually would like to correct that for you, including the results for Stanford Cardinal. If you really meant with this D here, then you can actually click that, then you get a new result, a different result. So that's actually what's really happening here. And that's really my personal favorite feature, the all-time favorite feature with simple line, and you have this dialogue to disambiguate with the user. Say, you probably typed it wrong, but who knows? You might really meant that. So that's really what's going on there. And once you have enough online data, then you have enough statistics. You actually really know what's going on there. So this is another example that's it's also interesting. For certain queries, we actually have a lot of structured data, like camera. So camera, we actually know a lot of things about the camera. It just can be building our knowledge. So I say camera is actually in different categories, brands, megapixels, and this is the intent disambiguation here. And there's a possible intent in camera. It could be really also meant camcorders as well. Then you have the top intent when people search for camera, likely they search for brands, megapixels, and other important attributes. And then also people typed before. They actually say when they search for camera, they also search for some accessories. So this is another example. Say, well, if you continue, say, well, you actually look for camera, but you look for Nikon. Then you can look at Nikon and say, well, we actually have some suggestions for Nikon. We understand so much about Nikon. You go from there. You say, well, I actually really care about the 14 megapixel. You click that, we bring you to more rich representation here. It actually works out really nicely for certain queries where we actually have a lot of structured data. The challenge there is actually data sparsity. Very quickly, it doesn't work for many of those queries because you just simply don't have enough structured data to really power that. People have worked on facet search for a long, long time. It never really took off for web search because the web search were not really able to come up with this kind of structure very nicely. But it does work very well, and as we have tried and shown to the users, and it actually, especially for the products. So that really gets to a very interesting question, how we actually really think about the formulating this problem is in order to get the dialogue work, you have to have some kind of notion of semantic. And you really need to get those entities right. And you better start to prepare those entities if you really want to get some sense out of that. So for a long, long time, our optimization framework was really mostly about the query and the documents. The new thing in this dialogue model is really now more, if you want to get this meaningful dialogue, you have to get into the entities. So the whole thing really becoming is the Q, E, and the D. So the query, entity, and the documents. So let me just say a few words about really the challenges in building this kind of semantic index in the matching system. There's just a lot of entities. There's just really a lot of entities. You may hear from Google or Bing, and we're announcing that in the knowledge graph this, knowledge graph that, we have hundreds of millions of entities. You know what? Facebook can just come out and say, you know what? We have more than 1 billion entities for sure, because there are 1 billion people there. And but do you have enough those entities with rich data that's actually interesting? So those actually is a challenge there. So we're definitely on the path to build knowledge for billions of entities and documents. And we want to understand the trillions of relationships. So once you have the node, once you go beyond the web graph to start to build entity graph or people graph, and then you have a lot of edges. Those edges really practically are just relationships. So then you have to understand more those relationships. And in order to really use that for user task completion, then you also need to really try to understand the relationship between the web graph, the people graph, the entity graph. I think what we see today in our industry is that there are very few very clean entity graphs have been built by any company. There's some, but at the very large scale, there are very few. But this one entity graph, I think, is getting better and better as we go on, is really people graph. I would say everyone probably is familiar with Facebook people graph. They recently announced they have more than 1 billion people and 1 billion nodes. But there's another very interesting people graph, I would say, is LinkedIn. Probably even more clean and probably is, very interesting for certain applications. So those things are happening as we speak. So it's very important that if we want to make some sense, not only we want to work on those entity graphs, we just really have to work on the relationship between the entity graph and the web graph as well. The reason really is very simple. It's actually entity graphs as we build, we actually have got very little feedback with those entity graphs until recently, and they're really very little. On the other hand, we have accumulated a lot of knowledge with web graph. So by leveraging that, it's going to be very powerful. So let me show you a couple of examples as entities. This is we get John right this time, and typing his name right. So look at that. Say, well, people who searched John also searched for some other interesting Stanford people. Well, we do have Dave Patterson here. I guess Dave did write a couple of books with him. Of course, you don't come to Stanford not paying enough respect to Don Knuth. Don actually wrote a lot of books, way more than those 4 we listed here. And I think another interesting thing we probably should do is list the numerous awards he won, and including what we announced today at the reception. So the interesting things you can do. The challenge there is actually it's not clear and how much you should really put it here. Even so, the query is pretty clear for Don Knuth, and Don has hundreds of those attributes associated with this entity. Which ones we should show? What people really are interested, what people are searching for. So those things are still the relevance problem as we go on. Here's another interesting example. Say who won the Oscar for the best actress in 2011. Turns out it was Natalie Portman. So the movies she has worked on, and those related people, others also searched. So they are really when you talk about entities, they are really people, places, and the things. So we talked a lot about the people, and there's Lady Gaga. Oh, this is actually interesting. So Lady Gaga is we actually have this music deal with a lot of providers. If you search for Lady Gaga, we actually pop up a few very popular songs that Lady Gaga has had. You can even click here and launch into a player, and you can start to listen. So places and Mount Everest is interesting, and so the things. So the not only we actually have this particular movie, and we actually have a cast and the reviews and so forth, and they have many other things you can imagine that USS Nimitz. If you're interested in those big boats, and those are queries that you might look for. So those are really entities that we have been building, and I think the whole industry is moving towards that direction. We are not alone. So I do want to say something about really understanding the intent as well, as we really continue to move on to design this dialogue model. So what's really unique about the search engine is that people are willing to give you a few words, give you a phrase, and something that in his or her mind. So it's extremely important that how much we can understand, not only lexically but also semantically, in what this user is really trying to say. It turns out that in order to really understand, we actually have to take advantage of a lot of contextual information. And just to show you three very interesting dimensions. One is the time, temporal. And let's just say, particular example, let's just say people here write the papers. I don't know what is the latest conference coming up. When is the CVPR deadline? It just passed, and the CVPR, if you type CVPR now versus CVPR later, and which CVPR you're looking for can be very different. And so this is this time dimension here. Certainly this is the location and the spatial dimension here. You type a library in Seattle, and you probably want to get to King County library system if you type library in New York City, and it's very, very different. I think those things actually, search engines getting better and better by using reverse IP and the other information, your registration and those things. But one particular dimension actually we feel extremely excited about is actually social. It's actually a piece of data is getting bigger and bigger, and it's getting to be very interesting. And if you are willing to log on and you are willing to share this information with Facebook, with Bing, then there's a lot we can really help you out. And you may want to do that anyway, because if you have a question, it's not only you can do, by asking search engine this question, you probably would do, in a normal social setting, asking some of the friends. I have to admit, not all the friends on Facebook are really friends, but you know what I mean. So you can ask other people's opinions. So let me talk a little bit about this social thing. So if you have enough this kind of social stuff, then you can actually think about different ways to use the social signal. Clearly, you can use the friends as a context, as a ranking signal. And so they might have liked something, they might know something, and those things, if you can index, then it will be good. So friends can also passively help, through the previous social actions I mentioned about that. And the friends could also actively engage to make the social better. And I'll show you some examples that friends can, for example, tag some information for you and point out certain documents actually really about you and mention about you, and you really should be, part of that particular documents. So I'll show you some of those examples. The challenge there is, of course, is really difficult, without this kind of social data. Now, we have been working for 15, 20 years, to improve the search engine. And we learned enough about from crawling to indexing to ranking, and how difficult it is, how we actually deal with all the spams and other things. Still, we struggle. Now we look at the social data, it's another open game, and we don't really know. And how do we really even define the social search quality? And how effective it is to blend the social signals into the overall ranking. How do we even measure that? How do we design experiments to really evaluate? The data is just somewhat a nightmare, and people typically in this kind of social corpus, they write very short things and they omit things, and the Twitter's definition is no more than 140 characters. So all those challenges we actually have to deal with. It's very early in my mind, by no means, and we have been successful here yet. But it's one particular dimension that we are very much on with the close collaboration with Facebook in particular, and also with Twitter and other social companies. I'll give you an example here just to elaborate a little bit that you might agree with me that the social signal is actually useful. So if you look at the Nokia Lumia 920, the latest smartphone from Nokia, then you have those three column layout. Then you actually have a particular page here, actually a friend liked. And how important is it? It's not clear. But a friend actually liked this particular page. So without randomize the order, the ranking order, we just say we annotate. We annotate this page and say, you know what, a friend of yours actually said something about this page, where he or she actually liked it. Then you look at it here, they say, well, there's friends and experts who actually might know something about Lumia 920. Apparently, Yuting's friends actually said a lot of things about Lumia 920. So it's another example, say Ian Ling, and they say, well, Ian, you have Ian's page here and in the middle. But they say, well, because Ian is a friend for Yuting's, and when you search, then you actually get Ian's Facebook page popped up here. And not only that, then we actually also say, well, we actually know something about Ian. There are some tagged pages about Ian. So latest articles on the web actually mention about Ian. And it's actually related. You could even click on this tagged small pages, and this really crowdsourcing by leveraging friends. Just do something to help Ian out about a lot of pages that Ian actually is involved. So then we also have there say, well, actually a lot of people actually might know Ian. So if you click that, you get to this particular page here. It's called the tags. So you have this tags page here. Then that's really Ian. You see, Ian's picture here. Then there are actually a lot of documents here previously already tagged. And you can find more pages tag, and you can continue this crowdsourcing to get more information about Ian. So you already have 15 pages, and you could certainly do more. And you can also tag other friends, even so this page is already tagged. Ian is involved, but clearly there are some other colleagues who also contribute to this Bing article here. There are some tags there too. Then you can find more pages to tag. So the last example I want to show you here is actually the recent close collaboration with Facebook, and we continue to roll out new features. And so one thing we actually tried is actually figured out how important it is about your Facebook photos. I don't know about you, and if you search Harry Shum and my name, if you search Harry Shum with a lot of Harry Shum pictures, and mostly about my previous life, I used to give talks here and there, and practically pretty old pictures. My latest pictures mostly actually on Facebook, and I'm not that public person, and I'm not posting a lot of pictures there. I have about 40 pictures, but those 40 pictures, at least to me, more fairly represented my life in the last 5 years. So there's a lot of very interesting things there. So we actually have this Facebook friends photo search here. If you search San Francisco on Bing, like Yuting logged on, and actually Yuting got a lot of people actually post a lot of interesting things about San Francisco. And so there are many other examples you can imagine. So I'm going to summarize my talk and finish this talk and by saying that search is a fascinating space. Search really is a research problem in my mind, and it's long-term battle, and it's long-term commitment to really build best quality search engine. And Google is incredibly strong and being ahead of anyone else for a long, long time. But Bing is coming behind, and hopefully we give Google a run of money. And if nothing else, we'll keep Google very honest about the search results. In order to do that, and we have to really build the core experience right. The relevance has to be good, search quality has to be good, and more and more, we think about the core experience as a task completion here. And secondly, I would say the way we actually have been thinking about it, hopefully it has been clear to you, how we have been thinking about it is really with the guidance of this information architecture, with this 3-column design of Bing node, web nodes, Bing nodes, friends node, and communicate the information that you are looking for. The model we have is really this dialogue. And the way we do that is we have to get into more semantic. We have to get into more entities and knowledges. We must have this intent and the interaction together. Again, it's really long battle, and I hope that we have more people in Stanford start to use Bing and give us more feedback. I know you all have been waiting for questions. Ask a question, please.
Sure, like the dialogue model.
Yeah.
How do you make sure that users acknowledge it and use it and don't keep on treating it just like the 10 blue links?
I'm not sure I completely got the question. When we introduce a new feature, how do users notice it?
Yes, and how do you make sure that sort of the just the average non-power users take advantage of it?
Right. So that's a very good question. So how do we know, when we rolled out of the feature, actually the users actually notice and the users actually use? So the good thing about working on any kind of online products is that you actually have a chance to collect a lot of user data. Of course, again, you have to be careful, anonymous and all those things. But you actually have a chance to especially look at aggregated data. Like I'll give you an example is one thing we actually care a lot is called the click-through rate. So if you have a feature that is clickable, and let's just say the Don Knuth, the example there, and the Don's there's like four books we put there. How do we know if that's effective? Well, we actually just need to compare if those 4 books got clicked. And by design, I actually would assume that the one at the very left get clicked more. And so all those kind of things we build into model. If it's not, then we will revisit and we go from there. But there are plenty of signals we can have. And the click-through is one very good thing. The other very common parameter we use actually is dwell time. Someone go to a page, did he or she stay there long enough? Then you more or less know. It's a good heuristic. Yeah.
So in the last part, you talked about what friends know and how you're integrating with Facebook. So how do you deal with the crossover from a privacy perspective? Because as the end user is using the search engine, you're pulling in relevant data that can't be anonymous because it's friends.
That's a fantastic question. We take privacy extremely seriously. The way we do that is actually we have our privacy policy, how we actually communicate with users, what data they use, and should they be prompts before we turn this feature on. So that's the Bing side. Because we collaborate very closely with Facebook, we also have the Facebook side of the privacy concerns as well. So everything we do with Facebook data, we strictly follow Facebook privacy policy as well. And in terms of, for example, that one very interesting thing you can say is you log on Facebook and then try on Bing, and the one thing you probably notice that the number of your friends is actually smaller than showing on Bing, and is actually smaller than the number of friends you see on your Facebook. The reason for that is actually a lot of your friends actually turned on some permission that you actually don't see that. For example, I don't see that. I don't see my wife there. She's just very strict about privacy. So we actually take that very, very seriously. Yeah.
First of all, when I type Harry Shum in Bing,
yeah,
my first hit is Harry Shum Jr.
Oh my goodness!
And and the second one is Harry Shum Jr. shirtless.
But what is your question? Are you saying Google sucks or Bing sucks or both of them suck? Or Harry Shum sucks. So
so when you speak about modeling intent, how detailed do you mean this? What I mean is, the canonical example is you type in a query, next train to Boston. Now, if in fact there's a train strike, then you'd like to get, well, the answer is a train strike, but there's a bus is leaving and so on and so forth. For this, you need to model things in a very detailed way about what is the plan of the user and so on. How far down that road do you want to go?
I would say we are very early, and it's a great question. I get to your main question. Let me make a quick comment on Harry Shum example. So I actually challenged my team, and I actually have this official Harry Shum challenge there in the Bing team, and It's really about the name disambiguation or entity disambiguation in general. I used to be somebody. Long time ago when you searched for Harry Shum, Harry Shum from Microsoft Research did pop up as #1. Then later on, something happened. This is the guy, his name is Harry Shum Jr., no relation to me. And he's a dancer. And it's incredible. You can see that on YouTube. And also he plays in this apparently very popular TV series called Glee. So he's actually in Glee. So the girls will just look at the guy and they just scream. So he actually became very popular and just continued to move up. Actually, he did move up even faster in Google than in Bing, and pushed me down further. But that really is something I have no problem with that, just to be clear. And I think, but in order to get back to the user, to me, I think the important thing is dialogue. Important thing is really the dialogue, because we now know there are two reasonably dominant entity, all related to Harry Shum. It's the Harry Shum Microsoft and Harry Shum Jr. And just have to present that back to the user. See, did you really mean the should list, or you mean the computer scientist? So that's really something we really need to do. But if you actually, there's a different way to really solve that problem. I would say is that using social signal. For those people who actually care enough about Harry Shum of Microsoft, you can probably do that. If you and I are connected on Facebook, which we have not yet, if we are connected, if you log on Facebook, you search Harry Shum, the first result will be your friend Harry Shum and the Facebook. So at least you get that part right. And then we can imagine a lot of things we can do from there. Then back to your main question about the overall intent. I think we're far from that. I'm not confident that the current architecture will take us there. And by that, I really mean both Google and Bing. And by and large, the apparatus, the incredible system we have built, is still more or less what to do with the web graph. There's very little understanding about the intent there. And we're making some aggressive push there. But as you can see, and you can try, you go home, you can try Bing and try some queries. So we're really not there yet. My worry is actually, if we are too aggressive in terms of pushing a lot of those intents, like your famous example is say, when is next train to Boston? As you said, I could be 25 hours away, and it does really involve multiple layers of understanding of the intent, getting there, building a lot of knowledge about the train schedule, understand the context about your location, and so forth. The direction is clear, we're moving towards that, but the current user interface in the simple white box with one line very likely will need to be changed to accommodate that to get there. And people start to use speech, for example, but I'm not sure that is necessarily a shortcut to get there.
You mentioned click-through rates.
Yeah.
One of the more successful types in advertising, retargeting has among the highest click-through rates.
Yes.
Because they follow you around.
Absolutely.
That's more context. Is that the sort of context you're looking for? We're following people around to sort of look at their other behavior, not just their search behavior, not just their Facebook behavior, to make their search results better?
Well, first of all, I would just say that you need to be very careful when you track people, the behavior and a lot of those things, and you really need to do that in a transparent, respectful way, and you really need to communicate with user what kind of data you use. And I think that in our industry nowadays, there are a lot of discussing going on, and they look at the major browsers now. They all implement. I think finally, I believe Chrome is doing that. Do not track policy. At least you give the user some choice there. Now, if the user is willing to opt in, is willing to give you a lot of data, I think this is actually very, very useful and powerful data. And as you said that rightly, so ads retargeting has been so powerful, and you went to some other website looking for some kind of truck, and now by the time you search for some things here, and the search engine does know more about you if you can aggregate this kind of information. And you need to do that carefully. It is very powerful, and the contextual information, I would just say, has not been as successful in search compared with in ads. In my opinion, for a very simple reason, that is search quality in general is much higher because this retargeting thing is really mostly a more recommendation, and so the quality If the quality is more comparable to ads, and it's likely people will click more, but if the quality is significantly lower than search,
The retargeting is solving a problem with ads, namely that online ads are inconvenient at best. They're never there when you want to see them. That's the problem with online advertising. That's the problem.
But I would say, I largely agree. I would say that's particularly true for display ads. For search ads, it's significantly better quality compared with display ads because you do give some intent to the search engine and we can optimize. But as I already stated that even in search ads quality is significantly lower than search results. Yeah. Yeah.
I'm from Japan, and I sometimes find the Google results show the Chinese text, which I cannot read. And do you have any comments on that improving the multilingual adaptability for the search?
I'm not sure I completely got your question. You are saying that you actually search some Japanese query, and you actually got the result with the Chinese result, and from Google.
Yeah, or if I put an English search, but I got a Japanese page or some different pages.
Yeah, without knowing a lot of details, my suspicion is that you probably should set your market and the language right. Maybe you should give it a try. And it doesn't sound right, and it sounds like it's some simple things. Are you searching here, or are you searching in Japan?
Yeah,
what you're saying?
Here in the United States. But
if you say so here's the thing. So what the search engines typically do is they say, well, there are a couple of things you should really set. Are you searching United States? Are you searching English? And you can still search in the United States, you can search Japanese, and you can be in Japan search English as well. So depending on the market and the language setting, and it's actually reasonably sophisticated, and you have to think through. And typically, the search engines will optimize towards the majority of the users what they're really looking for. And I'll give you an example that I'm personally more familiar with. Say in China, someone in China search a term called Jackie Chan, the Kung Fu star. And what type the Jackie Chan in English, Jackie Chan? Should we serve the user completely English content, or should we serve the user some Chinese content? So turns out, for a query like Jackie Chan, most of the time, the Chinese users in China still want to see significant Chinese content, even so the query is Jackie Chan. So, but those things you have to learn. You can flight. You can just say, why don't we just give some users, all English, some users Chinese plus English, and we do those things. So that's actually. But your experience seems to be a little bit surprising to me, and you might want to check your settings, language and the market settings. Yeah, sometimes they do mess up. At the back.
How Bing Dialog model is related to PowerSet?
Oh, PowerSet. How much the Bing Dialog was contributed by PowerSet? Is this your? For those of you who don't know, I actually acquired a company called PowerSetBing.com, and it was a pioneering natural language search company. And I actually showed Barney's name earlier. Barney was a Stanford graduate and a very successful entrepreneur. So there are a lot of technologies from PowerSet actually now in the core engine of Bing, and I would say they made a significant contribution to not only what we can already show today, but also shaped a lot of our thinkings. So I would say there's really significant. A lot of natural language technology itself is already in the search engine. Yeah.
So if you look at question answering systems and competitions like Trek, they seem to have focused more on get the exact right answer. You only score if you do, right? And what you're saying here is what we really need is a dialogue system which people can refine their questions and actually understand what they need to ask to begin with. What would you think would be a good metric to measure dialogue system accuracy by?
That's a very difficult question. I often say that the metrics team, I usually just say, I go to every team, I work with multiple teams, and every team I ask, say, who is your metrics guy? And typically I would say, who has highest IQ in this team? And then we should put this guy on metrics. This is such a difficult problem, and it's not very clear. I would say I can give you a high-level answer. What I said before is really, with this dialogue thing, the right metric is really the time to complete the task. So you have 1 step, 2 step. So remember that until now, the competition say get the relevant thing and get it fast. So you minimize the query and the URL matching, but that will be always the core. But that's really the game so far. But now you're saying, well, you know what? No, let's say one search engine takes 900 milliseconds versus the other one takes say 700 milliseconds. That's really no big deal if you actually compare with say this search engine only requires you to do 2 searches. The other search engine actually needs you to do 3 search engines. So then I think that's how you really think about the difference and how to measure the effectiveness of dialogue model. Yeah.
I'm going to ask a different question. So to me, one of the most difficult frontier and challenge in search is actually not text-based search.
Yeah.
Is, let's say, images-based
right,
search,
right.
even sketch-based search.
Right.
That seems to be an area that no one has cracked.
Yeah.
What's your comment on that? Is Microsoft trying to, is your Bing team developing secret weapons for that? How is Google doing?
Yeah, so it's a very good question. The question is that, we talked a lot about text-based search, what about the image-based, content-based image search, for example, show someone a picture, can you find something similar? There are a couple of things I can share with you. Number one is that we actually tried a few things. The first one we actually ever tried was done by my students in Beijing, was really something called finding similar images. My favorite example is actually you type a query called Van Gogh, and then you have all his paintings coming up in image search. Now you say, well, I look at those pictures, say, I actually like sunflowers a lot. Then you click on one of those images, say, can I find more similar images like this? Boom, just like that. Then you get all the sunflower pictures there. That worked okay. A lot of people actually kind of like that. But overall, and in terms of user experience, we have not found, people's needs for content-based search that high. So that's actually a little bit disappointing to me as a vision person. I would thought that the people would just say, look at, wow, my goodness, why don't we get this thing? I guess that is just not really clear, the intent there. Say, what do you mean by finding similar images? And let's just say you can find similar images. What's the next task for you with that image to do what? I think it's something there. I think it probably for Google and us, something to be desired. It's not clear. It would be good to compare notes with Google engineers, how they actually think about this.
Yeah, but although the other feature we have was actually finding the same image but with different
sizes.
That actually we did find a lot of users.
There's a lot of people actually use that. Yes.
That's a deep dupe.
Yeah. So, you have a question?
Yeah, actually, you mentioned the competition. Well, most people don't realize that when Larry and Sergey wrote Google here, their classmate Luis Gravano actually invited everybody who wrote a search engine, including your own Microsoft people, back then to talk about it.
Yeah.
And so Larry and Sergey actually kind of benefited a lot from Luis bringing those guys back.
I'm sure.
But I'm curious, how do you think both, you haven't mentioned Wolfram's alpha or, I forget what's his name's, Ask as well too.
Okay.
How do you do that?
Well, maybe I just add some comments that, you guys probably don't know, and I worked very closely with Stephen Wolfram for 3 years, and we actually had a deal with them. We popped up quite a bit Wolfram results on Bing, and it was way before Google Knowledge Graph and other things, and it became more popular. We actually tried. You can still go to wolfram.com and try. And it's a beautiful site. I told Stephen that he has 2 big fans in my family, me and my son. When we work on some calculus problems, so we still really use the Wolfram. But for a lot of entity kind of queries, I think they are interesting, but they are not interesting enough for general users. I think they're trying, and for example, I hope that's public knowledge. I believe that they do power number of scenarios for Siri, for instance, and there's a lot of things that they do very well. I still come back to my main thesis here. That I'm a big believer of this dialogue model, and I just feel that today our technology is not really there. And I get back to Yuev's questions that we're really not there to just give you that. Ask me a question, give you that. I mean, you can feel lucky every day, but you don't really get everything you are looking for. I'm just being very realistic here. Yes.
Now that Google has taught us to teach Pigeon, and Bing has followed suit, is there any chance for natural language where you can actually say what your intent is?
My
you
goodness.
guys never going to do that for us?
My goodness, well, we really want to do that. And we really, really want to. I don't see Chris here. This morning, I actually spent 30-some minutes with Chris Henning and talking about the power of natural language. We love natural language. Let's be very clear. We love machine learning. We have been on this thing, but they are hard to use. And if you follow, I assume you do, and if we follow the progress of natural language, over the years, and it's really the successful scenarios, the examples are really data-based. So it's data-driven. It's really mostly a lot of progress there and over the years, and really you have a lot of data. You try to leverage a lot of data to really get there. And we leverage, for example, statistical machine translation significantly. It's just beyond what I can talk about here. It's just it's really helped. So those things really matters. But the problem is that when you say why do you use more and say natural language stuff. We actually do. We certainly do. We try to use a lot of things. The question is really saying what is the user scenario? What are the kind of queries that we can answer better by using what statistical natural language processing method to really help? And so we take a very practical approach here right now is basically we're saying we really need to deal with both the queries and the documents to get some sense of that. Someone asked me about the power set. We actually processed natural language processing, a lot of processing there, and really try to understand more about the relationships, the synonyms, and the other things from, for example, the very high quality product called Wikipedia. So we did a lot of those things, and we found that the contribution from those series processing of the documents has not translated to significant gain in terms of overall search quality. So on the other hand, natural language processing of the queries start to really show a lot of power there. If you really get some entities right, even so it's only a very short phrase, and you really get it right. In a way, I would say, give credit to, say, Stephen Wolfram. What Wolfram did, for example, is whatever your question you ask, I will get your entity, dominant entity right. Then I prepare a lot of information, say Don Knuth. As long as this question is about the Don, I just boom, give you everything about the Don. You go find anything related to Don. Don's birthday, Don's books and lectures, everything, awards. Yeah, we are, just to be clear, we are
but
on
natural language like Siri and the Google product drive you more in that direction?
I don't know if I can give you the answer that I heard from UF this afternoon, and so. I think Siri is a fantastic product and very interesting and pointing out the direction, but it's not like a direction we never heard before.
No.
I think it's a long-term technology battle, and we get to a certain point. Speech recognition aside, and let me just say, in terms of natural language understanding, query understanding, intent understanding, to really answer the kind of questions. I'd love to talk to anyone who actually regularly uses Siri beyond one particular scenario. I'd love to, if anyone here, I assume that, people in Silicon Valley are mostly iPhone users, and I'd love to hear from you, how useful you found in the series. And I think the direction is right.
Now Google's starting to compete in the area. So
actually, Google is doing pretty well, and they look at so they have a lot of Stanford graduates. They better do well. So.
Okay, with that, I think Harry can still hang out for a few minutes before we